So, in order to make my mordant from the clay, I need to make an extraction, because it is not the aluminum is not readily soluble. The one which is in the clay, it is under the form of aluminum hydrate. You know that the clay has plenty of water in it, so that's the potter needs high temperature to eliminate this water. But for us, it is interesting because with some alkaline substances, I can separate the aluminum under soluble form from the clay, any type of clay, of course, with any type of ashes. So this is wood ash of poor quality, but it doesn't matter. I will strain it first because there are plenty of charcoal, so I don't need all those dirty things. So I will have the fine finest part. Oh, it took a bit of humidity, I'm sorry. Okay, so that's the charcoal and different part, and that's the finest part. So first, I will make what we call potage. So I will have hot water on that, and then the soluble part of the ash will be extracted. This is potassium carbonate. So, I'm sorry, I'm explaining the chemistry of the things because lots of people think the chemistry is kind of recent discovery by a kind of crazy scientist. From the very beginning of humanity, people were doing chemistry. So that's obvious. You know what we say about humanity. Human being is not different from animals because he is doing tools, because so plenty of animals are also using tools. Humanity became so developed because they discovered the fire, how to make the fire. So the first discovery of humanity is the fire, and the second discovery is the ash, the ashes, because inside of the ashes there are very, very interesting things that we will see together. So actually that's the solution of ashes here. And then I will add something in my solution. I will do it twice because actually I have lots of sediment passing through. So I will repeat that. So a bit more water maybe. So now I will let it sediment here to keep the very transparent juice. So that's a solution of potassium carbonate. And then if ever, imagine in my bonfire I have some shells, because I'm kind of prehistoric guy, a bit Frenchy prehistoric guy, so I put all my snails in the chimney, so I have plenty of shells. So during the time I'm burning my wood, I'm also burning the shells, and it makes lime. So by accident I also have some lime together. So the potassium carbonate plus the lime is generating potassium hydroxide. So that's a very, very interesting reagent, because this reagent is the one we need to make the extraction of the clay and to prepare the mordant. So all that could be done, you know, by serendipity, so by accident and observation. But it could be also a kind of trace of science from the very beginning, because the definition of chemistry is the study of properties of bodies and their interactions. So by just observing you can learn chemistry, and of course the conclusions must be clever, because sometimes if your observation is okay but not the interpretation, you do not succeed. So that's the reason why it became a science, so you know, to fix the rules correctly. So actually I have my potassium carbonate and then I will let it sediment a bit and or filter, and then I'm looking for some clay to treat that. Okay, so I will prepare everything to work on the clay, put a little bit of lime in it to get my special reagent to have my extraction of aluminum hydrate. So this is my solution of ashes. It is not my best, but if you have wood ash or hardwood, if you have oak ash, for example, that's much better. So this is not strong enough to separate the aluminum from clay. So I will have a little bit of lime calcium hydroxide. So this is making the caustic potassium. Here I'm changing the composition, and this is the clay from potter, local potter. He was kind enough to bring me different kinds of local clay. So he is harvesting the clay in the wild, and of course it is not a super pure preparation. So we can imagine that you will easily find a clay adapted to your practice. So for example, you can go to some potter's shop, of course, or ask to any potter locally, or go on internet and pick, could be any type. In this region we have kaolin and kaolin derivatives, which is a good subject. So okay, I have my potassium here. I put some clay, and then I will cook it for a while. So that's an empty pot here. I will cook it for a while to improve the extraction here. Maybe one more pinch to be sure. So I'm very pleased to show you that, because lots of people think that we are using chemicals, heavy chemicals. Lots of people think that aluminum is something super noxious and toxic, but you know, almost everything around us is based on aluminum. The tiles, the ceramics, all pots, all bricks, and so many things are made of aluminum, because this is the most common metal on earth, and this is the third component regarding the abundance. So, and the third is aluminum. So we cannot survive without aluminum. Anyway, I would say that for external use it has incredible properties. With this aluminum derivative we were developing in the past, so the tanning height, you know, for furs also, and so many things regarding the dye activity. And this is the proposition I have. This is logwood chips made in powder. This is empty pot and water, so I will prepare a dye pot here with a pinch of that, and then I will use this solution to cover one piece of fabric. So okay, for the test I just need that fabric. This is a kind of second-hand cloth that we find at the flea market. And now I have to dry my mordant, and because it will be dried but still soluble in water, I will have to fix it. So this method was used at the very earliest times of industry, European industry, but then to fix the aluminate, the potassium aluminate, they were hanging their pieces in a humid room during days for the carbonic acid of the air, the CO2, to neutralize naturally. So it's kind of natural system taking time. So for this demo, I will just try and dip it in some kind of carbonic acid extract, which is the bicarbonate, the ordinary sodium bicarbonate, putting it here, and then it will give kind of effect of long hanging. So let's try that first. Okay. So that goes in the bicarbonate. And in the logwood solution, I can add a pinch of wheat brown. The wheat brown will help to, to keep the design in place. Okay. I have to rinse, of course. So it normally takes a little bit of time, but hopefully it's giving an interesting effect. So let's see immediately what is done here. And then you see that will be my definition of the mold. I created locally affinities in between the fiber and the color. So it generates a kind of pattern. Of course, the background is kind of stained, also stained by the tannin which is in the plant, but by repeated washings, only this color will be stable. So of course I can put it in during some time. Let me do the recap of what we did. We had some clay, local clay, any type. We had some wood ash. I highly recommend so oak or ash or different types, and then very well strained, even concentrated by boiling. So you have a very strong potassium carbonate, and then you put fresh lime, also. So you have your lye, so kind of potassium lye, and then in it you put your clay, and after some time, which is not necessarily very long, you will have the potassium aluminate. What we did here was to apply it, dry it, fix it in some carbonic acid solution, but it could be also at the air for some days, and then dyeing that in a dye pot. So that's interesting because you have two things you must be really careful. Test your ash is very good wood ash. It must be, if possible, recent and of hardwood. So that's the very best one. And then try your clay before you start with big pieces, because of course if you start to experiment like kind of wildlife style, you can do it in the wild with very simple things. Snails for the lime, wood ash, and you bring your textile and have kind of wild dyes possible. But then please test your ingredients before. So I can put it in here to increase the color, of course, and then from that I would like to have explanations about the different aluminum salts that we can use, because most of the participants, they will prefer to buy them instead of making them. But then at least we made some ones, so you understand how it is done. So this is the basic form of the aluminum, and then there's also an acidic form. So if I take same clay and I boil it in some acidic plants, so sorrel for example, with the sorrel decoction, I will have or oxalic acid. I will have aluminum oxalate. That's even a very good surprise in that case, because if you prepare the acidic solution, you will have both aluminum and ferrous modeled in the same pot. In case you have ferrous in the clay, you will have a tremendous extension, because some clays will give dark and some others will give brilliant colors. And then by playing with all clays and acidic or basic, you will have very interesting effects. And lately you can also buy some preparations ready-made, kind of pure chemicals from trade, and have an easy way to use it. I would say kind of beginning of the history of models. It means that it is not really optimized. So do not take that like a kind of ready-made recipe. It's not really a recipe. It's to exemplify that aluminum is everywhere and it's quite easy to dissolve under alkaline conditions with the wood ash, or also under acidic conditions, depending.